Thank you very much for joining me. Just like the intro video said, my name is Dr. Eric Labar. I'm a faculty member at the Institute for Advanced Analytics. I actually have had the pleasure of being able to work with Manning Publications recently to be able to do a new live project on how to be able to do time series in Python, specifically focusing on the idea of energy forecasting. So what I'm doing tonight, in all honesty, is a little bit of self-promotion. I'm going to be talking a little bit about really the data that we use in that live project and really trying to understand how to be able to explore data in a time series context. Hopefully that will get you guys excited about it. As always, if you want to learn more, you can go do the project itself, but feel free to reach out to me. I'm an easy person to be able to find online. It's something that you can always reach out, connect with me as well. More than happy to connect with any of you. So, alrighty. Sorry, I got to have some water. It's late at night. All right, so let me tell you a little bit about what I'm showing you here. And what I'm going to basically do, and hopefully if you don't mind, I have a little bit of music playing in the background because Lord knows I don't want to just hear dead silence when I talk all the time. So hopefully that doesn't bother anybody. There we go. But essentially what I'm doing here tonight is really just going to be talking a little bit about energy data. And specifically on focusing on that energy data, trying to understand a little bit about how to explore energy data and some of the nuances of energy data. And we're going to be doing all of this in Python. So let me show you a little bit about what we've got. I really am only importing a couple of different packages here to be able to use. Right off the bat, I'm looking at pandas, NumPy, and good old matplotlib. It's something where I'm actually curious to see what people actually use. So it's something in terms of matplotlib, that's what I've been trained on in terms of being able to do these kinds of visualizations that I'm going to be showing you. But I invite you all, again, we have a chat that's open. I'm welcome to talk to you guys on the chat as we do this as well here on Twitch. I'm interested in seeing what you guys use as plotting packages. So as you guys are seeing me do things, as always, if you see something in a different way of doing things, throw it in the chat. Let's talk about it. Let's see what we've got. I know Seaborn is another popular package when it comes to plotting. Again, my training's always been in matplotlib, so that's where I sort of stay. I'm debating on sort of investigating Seaborn a little bit more just to sort of see what it's got. All right. So I'm going to be looking at energy data. And specifically, I'm going to be trying to forecast hourly energy usage. Now, I'm going to be doing this hourly energy forecast really with real data based in the Pittsburgh, Pennsylvania area, somewhere around Duquesne or Duquesne. I don't even know how to pronounce the city correctly. And so, that being the case, I need to be able to gather the energy data that's there. I'm not going to bore you guys here on Twitch with watching me gather energy data. And I'm not going to bore you on Twitch with watching me gather weather data as well. Because as you can imagine, weather has a primary impact on energy usage. And that's exactly what we're going to see tonight. If you're going to try and forecast energy, one of the big things you've got to worry about and incorporate is the idea of weather. So I'm going to be looking at some weather data as well as some energy data. So what I've got here is just a data set that I've got, basically a CSV file on hourly temperature data from 2017, February 1st, to 2020, January 31st. Essentially, I'm grabbing 2017, 2018, 2019. I'm grabbing essentially 3 years worth of data. In grabbing these 3 years worth of data, again, I'm looking at hourly temperatures. Now, why would I gather 3 years? Well, I really want to try and understand some of the seasonality that may be going on with weather as well as seasonality's impact on energy. I don't know about you, but I know I use different amounts of energy in the spring and the fall as compared to the winter and the summer. And so again, I want to capture all of those effects by grabbing multiple seasons. All right, so I'm going to be looking at some weather data, and I'm actually going to be looking at energy data of the same time period. And this weather data I'm grabbing from a local weather station basically in the same area that the energy data comes from. All of these things are open source. All of these things are online. It's really easy to be able to look up energy as well as weather data and collect the very data that I've gotten here. Nothing too complicated. Now, I'm not going to bore you with sort of actually going through and reading it in. I've already done that ahead of time. I'll get to typing here in a moment when we start really graphing things. But I just wanted to give you an idea of what the data sets look like. In fact, hopefully give you a little bit of a sense of what the live project in time series would look like. It really is going to be an idea of working with real data to be able to try and forecast energy. So here's some of the real data that I was able to gather from the NOAA. All right, so in this weather data, I'm just looking at the first 5 observations here. I'm grabbing, again, hourly, what we call dry bulb temperature. So it really is just what is the temperature outside? What's the ambient temperature? For all of these different time periods. Again, starting here February 1st at 53 minutes past midnight. Then February 1st, 53 minutes past 1 a.m., and so on and so forth. At every 53-minute or every hour interval on the 53rd minute, they record basically energy usage. I'm sorry, temperature. Now, I've already cleaned this data a little. I'll be honest with you. It doesn't just come perfectly clean as you see here. They also record any kind of weather events that are happening. So if it's raining at the time, they're going to record rainfall. If it's snowing, they're going to record snowfall. And so I've just basically scrubbed it for only the temperature. I just want to be able to see what temperature exists there. Cool. All right, so that's my weather data that I've got. Now let's look at the energy data that I've got. Same idea. I'm trying to gather the actual megawatts of energy that are being used in the area at the time. So, in doing so, again, you see all of these different values, all of these different variables. Again, this is the raw energy data. What I want to do really is just focus in on this one column. This one column is the megawatts of energy that were used during that hour. So, this is the beginning time of the hour. So at the midnight hour, so from February 1st at midnight to February 1st, 12:59 a.m., they used this much in terms of energy. Well, all right, so this corresponds to that first hour's worth of energy that was used. That's going to correspond to this temperature here, essentially 37 degrees. That's what we're going to use. It's not perfect, but if it's approximately 37 degrees when they used this much energy, that's the idea. Now, like I said, there's a lot of data cleaning that goes on in the background with these data sets. I'm not going to go through all of that here because that would be the quickest way to put me to sleep. Now, maybe you're doing this to try and go to sleep. I don't know. But if you are, then I'm sorry. Unfortunately, I'm going to skip over that part. What I'm going to do instead is I'm just going to basically have these things combined into a CSV file. If you're interested in working through some of the cleaning of this data and combining it, again, take the live project. It's really easy to be able to mess with the raw data here. But I'm going to jump in and just go and grab the actual CSV file that already combines this data together. And I'm just going to look at the first 5 observations with the head function. Really simple, really easy. So with this head function here, again, I've got these first 5 observations. I've got the megawatts per hour that are used. I've got the temperature, and I've got the date. Awesome. It looks like our data is set and ready to go. Be very careful, though, on how Python reads in dates. One thing, if you're ever going to do forecasting with Python, that you always have to be able to account for. All right. So we have this date here, but if you notice, again, this is some cleaning that I did ahead of time just to be able to get this out of the way for you guys. I'm using the dtypes function on this pandas data frame that I've created because I want to see what these variables are sort of stored as. And what do we have here? Oh, date is, oh, wait a minute. Date's just an object. I don't want date to be an object. I want date to actually be a date time. I want Python to realize this as an actual date. All right, so one way to be able to do that is I'm going to be able to use the to_datetime function. With this to_datetime function on the date variable itself, now I've basically overridden my date variable, and if I look at the dtypes again, what kind of data types I have, perfect. Now I've got myself datetime64 as my data type. Now Python knows these are dates. And that's going to be helpful. Because what I want to do now is start thinking about the idea of what we need to look at when it comes to this energy data. All right, let's ponder for a moment. If you're looking at energy data, what things do you think would be common patterns? What would be important to know? And I'm just talking about involving time. When involving time and thinking about your energy usage, what are some common patterns you have in terms of how much energy you use? Do you use more energy during the day, or do you use more energy at night? If you're like most of us, you probably use more energy during the day, whether that is, at an office place or whether, you work from home now because of the pandemic. Either way, you probably use more energy during the day than you do when you're sleeping at night. Okay, so hour of day would be an important thing for us to look at. How does energy change at different hours? Okay, so it would be good for me to understand hour of day. So I should probably take this date variable and sort of take out the hour. That would be helpful to me. Okay, so great, hour's important. Now I want you to think about other things. What are some other patterns in your energy usage? Not just on hour of day, but maybe day of week. Are there certain days of the week you use more energy than other days of the week? Again, if you're like most people, you'll use more energy Monday through Friday than you will Saturday and Sunday. Why? Because again, people go to an office a lot of times, or even still working from home, people expend a lot more energy in the notion of working during that Monday through Friday as compared to Saturday and Sunday. All right, so weekday would be important as well. It'd be helpful for me to know what weekday it is so that I can understand a little bit more about sort of the day effects that energy usage may have. Okay. Which, not just day of the week, but maybe it would just be important to know, do I have a weekend? Do I not have a weekend? Okay, awesome. Well, let's go ahead and start grabbing some of this information then. So I'm going to play around here for a moment. And when looking at this, so let's take a look. And what I'm going to do here is I'm going to pull up another piece. Alrighty. So let's create a new variable. Let's do some of the things we've been talking about. Let's create an hour variable. All right, so I've got my hour variable. Well, what is my hour variable? Well, again, the nice part about especially pandas is the functionality that pandas has. Let me show you what I mean. So the functionality of pandas allows us to do something like this. So I'm going to create a new variable, essentially the hour of day. I'm going to use the date time index function and really the hour function in that date time index. But I'm going to do it on this date variable. So I'm going to take this date variable. I'm going to then extract the hour out of this date variable and store it as hour. So let's go ahead and let's do that. In fact, if you wanted to, let's take a look again. Oh, there we go. I've got an hour variable. So again, the 0th hour, 1st hour, 2nd hour, 3rd hour, so on and so forth. Oh, that's helpful. That's great. Awesome. All right, well, I want to do the same thing with some other things as well, like we said, right? So let's create let's see here. Let's create a day variable. Seems reasonable. So with our day variable, same idea. In fact, I'm just going to get lazy. I'll be honest with you. It's late at night for me, so laziness definitely takes over at this time of day. And we're just going to do the same thing, and I'm going to create a day variable. Again, if you don't believe me, you can always just take a look at it here, and we now have day, specifically here, sort of day of the week. Okay, awesome. All right, well, let's take a look as well. Let's also take a look here. All right. Let's create another variable. How about we create a weekday variable? Again, with the idea being a little bit different coding here to be able to pull this off, but still can be done. There is a datetime.dayofweek function. And what this allows us to do is it'll basically tell us whether or not we have a weekday. Perfect. Awesome. Well, again, let's continue. Let me double check to make sure I don't have anything in the chat coming up. Awesome. Good. No worries. No worries. Again, I'm going to get lazy here. Copy and paste. Let's do what month it is. I don't know about you guys, but for me, the month actually has an impact as well on how much energy usage I have. We'll see that visually here in a moment, but it is something to be able to think about. As I'm coding this in, I want you to think about that idea. Do you use different energy, different months of the year? Do you use different energy in the winter or the spring, the summer, the fall? I know I use less energy in the spring and the fall than I do in the winter and the summer. And we can talk about that and sort of think about why that may be the case. Last but not least, just in case there's a year effect, let's go ahead. Let's grab year as well. Cool. So now I've basically decompartmentalized this date variable. So I have date, but now I've also got the hour, the day, whether it's a weekday or not, month, and year. Perfect. Great. Awesome. Awesome. Cool. Well, that being the case, now what we need to do is we need to explore our data a little bit more. I've told you I've cleaned up the data a little bit. What I mean by cleaning up the data is really what I've done is I've gone in and I've taken out some of the excess stuff, but I haven't cleaned the data perfectly. It's something that we should always take a look to see if we have any missing values. Now, before we look at missing values, one good thing to do, we have date, but I want to index this data frame by date. So when I start plotting things and I start looking at things, it knows that date is my actual index. So we're going to do that. We're going to basically do df.set_index. And what is going to be my index? Well, the date variable is going to be my index. Live coding, as you can see. So, awesome. So now I've set my index to be date. Now, again, like I said, let's explore our data a little bit more. I want to know, do I have perfect temperature data? Essentially, do I have any missing values? That is a valid question, at least I think. And it looks like I do. Looks like I've got 37 missing temperatures in my data. Now, I could go through, I could pull up the Excel file, and I don't know about you guys, but, at least this time of night, basic math in my head is not exactly what I would want to do with. So I say I have 24 hours a day, times 365 days, times 3 years. Yeah, I've got like 26,000 different actual observations, and 37 of them are missing. Now, you might think, well, why don't we just ignore those 37? Well, when I'm going to be graphing things over time, I don't want there to be missing data. I don't want there to be gaps. So what I'm going to do instead is I'm going to interpolate these values. So one great thing to be able to use, and again, I just keep looking over here to make sure I'm not missing anything in chat. So one of the great things to be able to do in Python, especially again in the pandas library, is the actual interpolate function. So again, what I'm going to do is I'm going to replace the temperature variable. So I have temp. Okay. I'm going to replace the temperature variable with, as you can see here, again, yay coding, interpolate method equals linear. So what is this going to do? Well, basically, it's going to find missing values inside of my data. And let's imagine I have temperature. And, temperature has a fluctuation to it. During the day, it's typically hotter than at night. And so let's imagine you have some kind of fluctuation of temperature. Now, let's imagine you have a missing hour in there. So I have, let's say, 37 degrees, then I miss an hour, then it's 39 degrees. Well, what would be a reasonable guess in between? 38, right? Like we would essentially just be drawing a straight line between those two values and then connecting it with sort of a point in the middle. Even if you had two values that were beside each other, if I had 37 degrees, missing value 37 degrees, it's probably reasonable to assume 37 degrees. And so essentially what we're doing is we're just sort of drawing a straight line between potential missing points. That's what this function's doing. Nothing too fancy. It's just basically linearly interpolating our data. Awesome. Great. So let's double check some things here. You know, I've supposedly fixed my problem. I don't know about you guys, but every time I supposedly try and fix a problem, it doesn't always necessarily end well. So let's make sure we actually fix the problem, shall we? Oh, awesome. Great. There are no more missing values. Perfect. Cool. Good. Now, that was with temperature. Let's double check energy real quick. Again, I am absolutely lazy this time of night, so I am a big fan of the good old copy and paste when it comes to code. And so in my megawatt energy usage variable, no missing values. Perfect. Wonderful. Wonderful. Cool. Well, all I've got to do now is just sort of graph some things out and visualize some things. So let's take a look at some things. So for example, and this is where we get to have some fun. What I want to be able to do is I want to basically plot out what my actual megawatt energy usage is going to be. I'm going to add some options in here just for fun. Blue seems like a good color this time of night. Figure size, let's do 9 inches by 7. There we go. Alrighty. And then what I want to do, let me set some axes, some labels here, because, you know, I am a stickler for making sure my axes are labeled well. I apologize. That's just who I am. In fact, here, let me go ahead. I've got some axis labels over here. I can just copy and paste those over. Let's do plot.show. Of course. Again, live coding, these things always work so good when you do this. Let's see. Oh, silly me. Axis 1 equals. Again, got ahead of myself. Awesome. All right, so there's our energy usage data. At least, again, this is the pattern of essentially around Pittsburgh, Pennsylvania, for anyone who may be out there. Let's take a look and see what patterns we may see. Okay, well, it looks like, let's see here, this is around the summer months. So here's September, here's May. So right in the summer months here, we seem to have a higher amount of energy usage. Same thing here in 2018, same thing here in 2019. During the summer seems to be the highest peaks of energy usage. Well, let's actually look at the winter as well. Well, this is around that January time frame, right? You know, right when winter begins, so January, February. Oh man, high energy usage again here in January, February. Now, not as high as in the summer, but definitely higher than the other times, than these little dips. These little dips that you see here are basically spring and fall. Okay, all right, well, let's just try and make sure we've got all of this squared away. I want to make sure that I'm not accidentally messing anything up here. So let me go ahead. What I want to actually do is I want to sort of zoom in on this. So I'm going to do this real quick. I'm going to create a new data frame really quickly. I'm just going to create a new data frame that's only my megawatt energy usage. Again, axis 1, df underscore megawatt. What I want to do is I want to look at a specific time frame. Let's look at 2019, December 1st, and let's go to 2019, let's say December 7th. Let's just look at a week of data. That's all I'm going to do. That's all I'm going to do. Dot plot. Again, let's just pick something. Color equals blue. And let's just do, again, fig size equals a 9 by 7. Okay. Now, I'm not labeling the axes as prettily here, but you guys get the idea, you know, for good coding. Plot.show. So this is a week of energy usage. Oh, wow, look, this is a really cool pattern, right? So this is Sunday. All right, so this is the Sunday of the week. Very low energy usage. Then we have Monday, then Tuesday, Wednesday, Thursday, Friday, and then Saturday looks a little bit funky. But it looks like Sunday and Saturday seem to be the lowest energy usage of the week, while Monday through Friday seem to have higher energy usage. Well, that's really cool. That's exactly what we would expect there to be, right? Again, we were talking about that and thinking about that. So whenever we build our model, and again, if you're interested in building time series models, please do look into that live project. But if you're just interested in building a model on energy usage, whatever model you choose, make sure you account for the fact that different days seem to have different amounts of energy usage. Okay, awesome. Cool. All right, well, we've done that with energy. Now let's do the same thing with temperature. So let me go back again. Like I said, I'm lazy. It's almost 8:30. Let's go ahead. I'm going to copy paste. I'm going to call this axis 2 just to make sure we're all good here. I'm going to do temperature. And this is in degrees Fahrenheit, by the way. So I apologize for anyone who is used to Celsius, but I am looking at Fahrenheit. So there's temperature. There we go. Let's look at our temp variable. Again, now let's get a different color here. Let's go green. Let's see here. Oh, wow. All right, so look at temperature over time. Now this, again, makes sense, right? So again, the summer months are hotter. Again, we're in the northern hemisphere, so the summer months here are hotter. The winter months are colder. Okay, so again, all that makes sense. But take a look at this pattern compared to this pattern. Oh, it's a little bit hard to see sometimes, but I mean, just looking at them, they're not the exact same, right? It's not that they're really not the exact same. So let's do this. Let's grab those axes again. So again, I'm going to grab my axis from up here. I'm going to grab my axis number 1 on megawatt hours. Okay, so I've got my axis 1. What I want to do is I'm going to do axis 2 equals axis 1 dot twin x. Okay, and then what I'm going to do is I'm going to grab my axis 2 from here. So axis 2, and in fact, we'll grab the y label as well. Copy that, paste that, plot.show. Now I've overlaid them on top of each other. Okay, so it's weird, right? So it looks like that temperature seems to spike when energy seems to spike when temperature spikes, but energy also seems to spike when temperature dips, right? Like the lowest energy usage is actually on these downturns or upturns of temperature. Let's think about that. I mean, I guess that would make sense, right? Again, in the winter months, where it's the coldest, I have some spikes in energy. The blue spikes in the winter months. And I have some blue spikes in the summer months when temperature is the hottest. You know, maybe it's a little hard to see. So let's do the same thing. Let's do the same thing. I'm gonna overlay this stuff. But what I want to do is I want to be able to do this sort of, again, on a smaller scale. Make it easier for us to read. So again, I'm going to create a new data frame here. Okay, just to make sure we're all good. So I'm going to create a dfmw. I'm going to create a dft. Again, I'm just creating 2 new data frames based off of my temperature, based off of my megawatt hours. Again, there are a variety of ways of being able to do this. So again, what I'm going to do is I'm going to grab this piece right here as my axis. Let's take a look. Again, now let's take a look. Maybe we want to look at a different time period. Let's look more winter, more in the dead of winter. Let's say January 6th through January 12th. How about that? Again, so that's going to be my megawatt hours. Again, same thing as here. Copy, paste. So I'm going to set the same labels. I'm going to do this twin axis thing again. But what I want to do here is I want to now take this look at the exact same time period, but I want to look at temperature. Again, let's make that something different. Let's make that green. Again, now let me grab my Y label from up here. Cool. Awesome. Plot.show. Let's take a look, right? In the winter months, what do we see here? Well, when it gets really cold, energy seemed to spike up higher. Now, don't get me wrong, energy still has this, daily effect where at night people use less energy than in the middle of the day. That still holds true. But the coldest days of this week had the highest energy usage. That can't be a coincidence. Right? It's probably because the fact it was so cold, it took more energy to be able to heat the buildings of which they were in. Again, I don't know about you, but for me, AC is the biggest way for me to be able to control my hot in the summer, and heating, and I have electric heating, is the best way for me to control my heat in the winter. And so again, the coldest days seem to have the highest energy usage. Okay, well, let's do the same thing. Let's do the same thing. But now, instead of me looking, let me, again, copy and paste, baby. Works so well. Instead of looking in winter, let's look in summer. Let's see what we see in summer. Again, let me double check, make sure there's no one there throwing some questions out in chat. Cool. Again, as always, if you guys have any questions, throw them in the chat. I'm more than happy to talk with anybody. Let's take a look. Oh, wow. Now, this is really cool. It looks like in the summer months, we see that there's almost a one-to-one correspondence, right? At least, now obviously the values are not going to be the exact same, but in the pattern though, it looks like that when it's really hot during the day, that's when people use the most energy. Well, they're also using the most energy because they're awake. But again, we can see where there are hotter days, where the green is higher, you have more energy that is being used than on colder days where the green is lower, less energy gets used. Okay, so there seems to be this correspondence here of energy and temperature. They seem to be related. But again, this relationship seems a little complicated because in the winter months, low temperature means high energy. But in the summer months, high temperature means high energy. So I know. What we can do, and what I want to do here, is I want to actually plot this as a scatter plot. So let me do a scatter plot here. So a scatter plot, again, df of temp as well as df of megawatts. Let's set a little bit of transparency so we can see things a little bit better. Again, what I'm going to do is I'm going to grab some labels here. I've got some preset labels over here to make it easy for me. Oh, whoa, look at this. This is really cool. Again, it shows that there is a relationship here between temperature and megawatt hours, or again, temperature and energy usage, right? So there is an actual relationship between temperature and energy usage. But in this temperature-energy usage relationship, it's complicated. It's not a one-to-one kind of thing. It's something that, again, when temperature's really high, there's a lot of energy being used. When temperature's really low, more energy gets used. When temperature's right around this 60-degree mark, I don't know about you, but that, to me, perfect outside weather, right? So when temperature's around this 60-degree mark, man, very low energy gets used. It just feels so good outside. Crack open the windows. Just relax a little bit. You don't need to use the AC. You don't need to use the heat. You just get to use less energy. That goes for buildings when it comes to heating businesses. That goes for actual individual homes as well. So it looks like, again, we see some kind of pattern that's going on here, where you have this idea that high temperatures result in high energy, low temperatures also result in higher energy, and middle temperatures result in the lowest energy of all. Cool, great. But so this goes to that idea of different seasons of year. But again, let's think about the idea in terms of a little bit more. So we've talked about, different seasons of year. We've talked about different times of day. Again, during the middle of the day, energy usage is higher, and at night, energy usage is lower. This pattern goes along with exactly what we expected. It's actually really neat to see this little bump, right? And so you have this little decreased bump here. It's like, people get to work and then they need a lunch break, but then they get back to work and then they go home. Or maybe this is the bump when you get home in the afternoon. It seems to be that bump that exists. So, all right, cool. Well, let's explore this scatter plot just a little bit further, and then we'll be done for the night. Okay, so I'm going to break this guy down a little bit more. Okay? All right. So when looking at temperature, and again, looking at this relationship with energy usage, let's break it down now to different times of year to, again, see the actual pattern. Okay? So again, we can kind of see the pattern in what we've looked at here. You know, relationships are different at different times of year because temperatures are different at different times of year. But I think another way of being able to help us explore this data a little bit would be a graph that looks like this. So I'm going to do some subplots here. Okay. So again, I'm going to grab a scatter plot. So again, sorry for you guys getting to watch me code. That's always ever so exciting. So again, what I'm going to do is I'm going to start using that month variable that we created. Remember that month variable? This is why it's important. All right, so I grab this month variable, and let's set the month to equal 1. So the first month of the year. Let's take a look at January. Okay, so we have month equal 1. And let's again look at the same thing. Let's grab this, except what I want to do is I want to do megawatts, where again, month equals 1. Again, what we're also going to do, alpha 0.2. So I'm going to, again, graph two scatter plots really on top of each other. Again, I'm going to grab my labels here. Copy. Whew. Paste. Let me do the same thing again. So I'm graphing two plots really on top of each other, except I'm going to change the months around. 7. So again, I want to look just a different way at this idea of different seasonal effects. So I have January going on. I've got July going on. Let's take a look. Let's see what we got. Oh, wow, this is cool, right? So you get a chance to see, again, that idea that energy usage is different based on different times of year, because a lot of times you have different temperatures at different times of year. Right? So in the January months, when January is going on, that's what I've plotted here, I have a negative relationship, right? Which is kind of what we saw all the way back up here. Right? It's that idea that as essentially temperature goes up, energy usage goes down in the winter. Because again, in the winter, the highest energy usage comes when we have the lowest temperatures. But these orange dots over here on the other side, though, these orange dots, these represent, again, that idea of summer, right? And summer's relationship. Summer has a different relationship. July has a different relationship when it comes to temperature and energy. In July, lower temperatures in July have lower energy usage, and higher temperatures in July have the highest energy usage. Again, really cool. We get a chance to sort of see this same kind of thing. This representation between these two charts is sort of really represented very well in this one chart here, because we're seeing that impact, again, represented on the same axes. Cool. All right. Well, one last thing to be able to explore. Let's do the same thing, but again, now let's go to that hour of day, right? So what I want to do here, I'm going to, again, copy and paste. So, but instead of looking at month, I want to look at hour. So again, I'm looking at hour, specifically what hour? Let's look at hour 0. Let's look at midnight. And compare midnight to, let's say, noon. Again, I don't know about you all, but I use different amounts of energy at noon as compared to the amount of energy I use at midnight. So, when looking at this, let's plot this out. Let's see what we get. Let's talk about it. Oh, wow, this is a little bit different. Well, actually, it would help if I, change this variable to hour like I was supposed to, because that looks horrendous. There we go. Whoa, this is really cool, right? So again, taking a look here, what do we see? We see at midnight, that is when the lowest energy usage is in this big plot. If we look at this big plot when it comes to temperature and energy usage, and if we look down here, the lowest dots in this plot happen to be midnight, or at least in the middle of the night. I'm sure if we change this to 1 a.m., it wouldn't be too different. Let's play around with it. Let's change it to 1 a.m. Same idea. The low dots are the middle of the night. Where the high dots, again, on the scatter plot, the highest dots seem to be around the middle of the day. Again, that's when energy usage is being used. Again, maybe we don't want noon. Let's look at 1 p.m. So that would be 13. So again, same idea. Same idea. And what we see here, that the relationship here is complicated. That this temperature and energy relationship changes depending on what month it is. It changes depending on what hour it is. Again, these are the things that we saw here. It's not just that energy usage is different for different hours. Energy usage's relationship with temperature is different at different hours, right? Because again, at midnight, you probably don't care what temperature it is outside as compared to at noon when you actually have control of the thermostat. I don't know about you guys, but at midnight, I'm not messing with the thermostat. I've already set it. I've gone to bed. But in the middle of the day, it goes, oh man, my office is feeling a little hot. I'm going to go over to the thermostat. I'm going to pump it down a couple degrees. I can play around with the temperature a lot more. And so again, we see that exact pattern going on here. We can see that these things change no matter where you are. And so that's really, really cool. So we've gotten a chance to explore a lot of nuances of energy data here tonight. So again, if you're really interested in being able to forecast energy usage, I highly recommend you go check out the liveProject. It's on Manning. I can throw up the link again. It's there as well. You can just easily search it, time series in Python on Manning. And then again, when looking at that energy usage, really, if you were to model energy usage, you have to start considering some of these other things that are going on. You have to consider the fact that energy usage is different in different seasons. Summer months and winter months have higher energy usage typically than spring and fall. That's a big thing. If you're going to be modeling energy, you need to account for that. But also we have this daily pattern as well, that during the middle of the day, people use more energy than during the evening and nighttime hours. Again, they're asleep. There's a baseline level of energy that is being used, but the biggest spikes in energy are used during the day. A lot of times that's from businesses. Businesses being open, their power being on. But as businesses close down at night, their power is off. The only thing that's powered on at night are homes, and even then, homes are using less energy than they typically do during the middle of the day. But then not only do we have that changes happen, within a day, we also have changes happen depending on different days of the week. Look at Sunday. Look at Saturday. Less energy is used on the weekend typically than is used in the middle of the week, Monday through Friday. Now, we can see Friday starting to tail off. People have gotten out of the office a little early. Maybe they don't go on Fridays always. And so we see this Friday effect is a little bit smaller than the other days, but it's not as small as a Saturday or a Sunday. So if, again, you were modeling energy usage, you now need to account for the fact there's different seasons that you need to account for, different days you need to account for, hours of day matter. Cool, great, but if you wanted to use temperature, and temperature is a good predictor of energy usage, again, we've looked at temperature's pattern. It's not the exact same as energy's pattern, so you can't just throw temperature in there as a one-to-one kind of thing in a model. It's not going to be helpful in a one-to-one relationship, but there is a relationship. It's just complicated. Right? We can again see here, just going over some of the stuff we talked about tonight, we can see that when temperature gets really, really cold, this green line gets really, really low, the higher the energy usage. And in fact, when temperature gets really, really high in the summer, the higher the energy usage. And if we wanted to explore that relationship a little bit further, again, here's the complicated relationship that temperature has with energy usage. When I see people modeling energy usage and using temperature, I see people using quadratic patterns, sometimes cubic patterns. Sometimes they just put a notch, a point here, let's say 60, 65 degrees. Anything above it is a straight line going up. Anything below it is another diagonal line over here. So almost like a piecewise function you can use. So that's another way of being able to model this. But again, this relationship is complicated, right? Because again, we see at different months, the relationship between temperature and energy is different. In modeling, we call this an interaction effect. So again, if you were building a model for energy usage, you need to account for this interaction. Whether you're using a tree-based model, whether you're using a regression model, you need to account for this interaction. That in certain months, summer months, the relationship between temperature and energy is different than in winter months. Which, of course, if we were to do this for spring, let's grab month 4, and let's do fall. Let's say month 10. When it comes to spring and fall, it's about the same. There's a lot of overlap here. Okay? Cool. And again, same idea when looking at hours of day. It looks like that depending on what hour of day it is, the relationship, again, between temperature and energy usage is different. You know, when you have hours that are in the early morning hours and overnight hours, less energy gets used than if you're right in the middle of the workday, where more energy gets used. So the upper points in this graph are a lot more of the energy happening during the day, and the lower points in this big graph up here are the ones that are happening in the overnight hours. Well, awesome. Cool deal. Well, I didn't see anything come in on the chat for you guys, but it's been an absolute pleasure to be able to talk to you guys tonight. I hope you had a fun time just exploring energy data with me. As always, it's been a blast. I'm going to hang out here on the actual Twitch channel in the chat room for a little while in case you're interested. As always, it's been a pleasure. You feel free to connect with me. It's really easy to. In case you needed, my name is Eric Labar. You can easily find me online, www.ericlabar.com. It has me on LinkedIn. It has me on Manning, so you can always connect with me that way. Again, it's been an absolute pleasure talking with you all tonight. You guys have a great night.